amongst my intentions in this tutorial is both to introduce you to information processing, but I also want to try and demystify it for you. And the reason I say this is because when I've taught this topic in the past, and when I've worked with students on this topic in the past, there seems to be a sort of a general kind of like, I find it harder than it actually isness to it. And for that reason, I really want to demystify and simplify if I can. So I want you to look at these 4 images. One of them has far greater information processing requirements than the other. My first challenge to you is, do you know which one it is? One of those performances has way more information to process and therefore is a more complex decision in the complexity continuum. Which one it is? Which one is it? And you should be saying, well, it's the baseball example, because effectively you're responding to the environment, the flight of the ball, the pace of the ball, the swing of the ball, etc., etc. Whereas all the others could be seen as almost like routines, couldn't they? So if we focus on our baseball batting, and it could be cricket, it could be rounders, could be softball, could be catching a netball, it could be all kinds of different things. But this has fairly significant information processing requirements. Why? Well, the first way that we can answer that, I'm going to get my little box, that's not the one, my little box setting here. The first thing I want to mention to you is that this example has quite a lot of information in what we call the display. Okay, so we've got this display here, and this display is all the information that this individual has to consider. It's all the information that this person has to take into account. Now, that information comes from both internal sources and external. Again, if you want to pause the video in here and think, okay, what information is it that I'm talking about? What is all this stuff? What is it that's in this display? I want you to be considering, for example, that we would be talking about every single stimuli, and that display produces something. It produces arrow, not specifically 4, lots and lots actually, and it produces something called sensory info. Okay, so let's have a think about what that sensory information might be. In our case, it could be light. Think about light in the form of the movement of the ball. It could be sound. It could be the ball whizzing through the air. It could be contact, contact between the feet and the floor, the bat and the ball. It could be things like how balanced the person feels, the equilibrium they experience. So all this information is within the display, and it is considered to be sensory information. Now, if you think about the human body, this baseball player, you, what do we have that senses this information? Well, not surprisingly, folks, let me choose the right thing here. Not surprisingly, if I just choose a different color, we have what we are going to describe here as sense organs. And your sense organs, this baseball player's sense organs, they are things, of course, such as your eyes, your ears. I'm going to throw in the word your proprioceptors, those being your muscle spindles, your Golgi tendon organs. We even have things like the middle ear, which senses things like balance, for example, equilibrium. But our sense organs, eyes are an excellent example here, are picking up movement, light, as that ball approaches us. And of course we see that ball by photons bouncing off it and hitting, going into the eye. Now, I'm not going to get into that. Go back to your GCSE biology. I'm sure you can do that. But those sense organs are picking up that sensory information. But this is where our model becomes interesting. All that information goes to our sense organs, how we feel, the balance we're feeling, the sounds, the images. It could also be completely irrelevant information, such as what's around us. Is someone shouting? Is there a crowd? All that stuff is relevant. And because of that, what emerges is just absolutely, notice my 4 arrows have gone down to 2, only sort of figuratively and representatively, because we now go through a process called perception. And perception, that's now the 4 arrows gone down to 2. Perception, what that means is that we filter out. We filter out stuff that is not important from the display. In other words, we undertake something called selective attention. We ignore all that is irrelevant. This baseball player, it's irrelevant what colour the pitcher's cap is. It's irrelevant what the crowd are chanting. It's irrelevant what the scoreboard says during the performance. These things don't matter. But what does matter is the speed, the flight path, the angle, the swing of the ball, and presumably also where the batsperson is trying to strike it, I guess. So we are filtering out. And because we do that, we can now take the relevant information forward. That's what those two arrows represent. We can take that relevant information forward, and we can now go through a process that we are going to refer to as decision making. Okay, decision making. And decision making, in this case, the batsperson decides to swing the ball through a particular arc. This happens in the short-term memory of the performer. And of course, we look at memory in other areas of the course. And three things happen during decision making. We get the idea of detection. Okay, detection, we detect those relevant stimuli. We've got the idea of comparison. Comparison, we compare it to information we've seen in our experience in our long-term memory. And then finally, folks, we go through retrieval. And with retrieval, what we are doing is we're retrieving the right movement from our long-term memory. And this, by the way, is called the DCR process. The decision making is detection of the relevant information. We compare it to previous experiences and we retrieve the right movement. So that is what this batsperson's doing. It's very rapid, by the way, almost instantaneous. This decision making occurs in the short-term memory. It's comparison to the long-term memory, retrieving the movement from the long-term memory, and then we implement that movement. How do we implement it? Well, we now have a number of outputs. I'll rephrase that. A number of what we're going to refer to as effector mechanism stimuli. Okay, so now we are going into what we call our effector mechanism. Now, effector mechanisms are the following. They are nerve impulses. Okay, so this is literally the triggering of the brain, firing nerve impulses to certain muscles. And this is also muscle contractions. So in other words, we have retrieved the swing of the bat motor program from the long-term memory, and we are now firing the nerve impulses to the muscles of the arms, the shoulders, the legs, around the waist, etc. And we are contracting the muscles in the right sequence with the right amount of contractile force. And what does that produce? Not surprisingly, folks, that then produces the response itself. So as a result of that, I meant to do that in a different color. Let me actually do that in a different color. As a result of that, we now produce. James, goodness me, we now produce. This is all this just for a different color, folks. We now produce a response, and that response is the movement itself, the swing of the bat, the actual strike. In this case, let me put it actually, it's the actual strike, the swing, the motor program. Remember, we've produced the motor program. It's now in the real world. We've done it, we've moved, we've swung the bat. But of course, what does this produce, folks? This produces, not surprisingly, information which now re-enters the display in the form of feedback. And that feedback, folks, comes in two formats. We've got internal feedback. This could be, for example, how the movement is feeling as you swing. And it's also external feedback. What was the sound, for example, of the bat on the ball? Did I swing and miss the ball and feel no contact? I suppose that would go towards internal. Did the ball travel into the space I was trying to hit it or go over the fence for a home run? That is external information. But as a result of that process, that is what's occurred. Now, can I stress to you, if you consider that we are triggered at this point, that's when the information is displayed, and this is where we start to move, that is what we would refer to as reaction time. Once we have moved, this is what we refer to as response time. Okay, so we can link this. Also notice the association between information processing and memory. We process information and then we make decisions based on what it is that we've experienced previously. Now, as I said right at the start, in our 4 examples, this is the example with the most information processing. So start to realize that complex open skills that are practiced in, let's say, varied practice environments. It's these skills that have lots of information processing to them. And actually, that perceptual load, we've seen there's a high perceptual load in the baseball strike. That high perceptual load is actually what causes a skill to be, for example, complex. And it's because of that it might, and we'll look at this in more detail in reaction time tutorials, but it actually might take longer to respond. Now, can I stress, this happens very quickly in trained individuals. It might be slower in sort of novice individuals, but once someone is trained, highly skilled, this is going to be a very, 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 very efficient process. However, do people still make mistakes at the highest level? Absolutely. Sometimes even high-level athletes miss things, don't get the right level of concentration, don't select the right information, and produce the wrong response. That, of course, can happen. Cheers.